Hey everybody, this is Paul Veal, November 0 Alpha Hotel from Colorado, Delta Mike 79 November, coming to you from Littleton, Colorado today. I wanted to make this video on the Cushcraft MA160V vertical because, quite honestly, I can't find anybody on YouTube who's ever built one of these antennas or described how to build it or the pitfalls of what you can run into. So that's what this video is about today, with the ultimate goal of earning your 160 meter DXCC. This award took me about 23 years to get, and I couldn't be any happier with it. One thing about top band though, for my four different operating locations, I wasn't on top band always. I got my start on 160 meters in Brighton, Colorado, where I was using 600 watts with an AL811, and I had a butternut HF2V vertical. While I was in Brighton, if I'm just kind of looking at some of my numbers here, my first 14 countries came from that HF2V, and 2 of those were Europe. Then I went up to Wyoming, where I had a contest station with an inverted L and 120 radials attached to it, running full legal, and ended up with another 67 countries on top band. But again, it wasn't my focus. I probably could have finished my DXCC in 2 or 3 years. I made the mistake of focusing on other bands and awards, and as a result, when I moved here to our house in Littleton, I had only 81 DXCCs in total. So I had 19 more to chase, along with a few cards in Wyoming that I still needed to track down. And I was able to do it. We did it with the MA160V. I did not run power, I ran low power, but as a result of getting my DXCC, I'm a very happy owner of my new amplifier, which I still haven't plugged in. It's been sitting here for a couple weeks now, and maybe eventually I'll get around to it. So that's what we're going to do, and let's go outside and take a look at the antennas next. Everybody, it's Paul Veal, November 0 Alpha Hotel, here to give you some good tips and advice on building a Cushcraft MA160V vertical for your backyard. I know a lot of us are in small homes or small yards, and even though we may not be in covenant controlled neighborhoods, that doesn't mean we have space to get on the top band. At least that is a paradigm that a lot of people have until you have a chance to put one of these antennas into your yard. The MA160 is anywhere between 30 to 36 feet tall. If you're going to be doing any kind of work in the CW portion of the band or around JT65, your antenna is going to be about 35.5 feet tall. You can see that I have the antenna guide not just in one, but we actually have a guide in 2 places. If you guide at the recommended area, it will keep it from tipping over, but it will also bend it like a noodle. So we found having a guide in 2 areas keeps it a little bit straighter, just for an aesthetic look. Also at the very top of the antenna, that's how you tune things. You basically adjust the top radiator, and if you adjust things about 1 inch, you're probably looking at adjusting things by about 5 kilohertz. Just depends on the antenna and your location, but that's about what we're getting. So 1 inch of the stinger accounts for about a 5 kilohertz shift. Now, what I want to really talk about is how in the world do we keep all the noise off the MA160. One thing you might notice, if I can get back to the antenna, is that our feed lines are always buried. If you have a buried feed line, as you can see where it's leading out from the shack window, that buried feed line going out to the antenna helps keep ambient RF noise off of it. Also, we have a common bonding area for all of our grounds that sits right below my utility box. So here's the utility box, and below it we have the common point ground. And this common point ground has all my antennas tied to it for grounding for lightning safety, but it's also grounded to the cold water pipe coming into the house in the basement, which is not always something you can readily find, but if you can, especially in an older neighborhood with all the piping underground, my ground resistance is anywhere from 0.4 to 0.7 ohms, pretty much no matter where we've measured along the system. And considering the industry standard for lightning safety is 5 ohms or below, we're doing a pretty good job with that. We've gotten really lucky. Okay, so let's go out and take a look at the antenna feed point next and see what we've got going on there. One of the reasons I'm real successful on top band is I don't have a long run to my antenna. Haven't been running an amplifier. Everything I do is on low power. So let's just take a look at the feed point area. and focus on a couple things that we have. First of all, that black box and tape is a unbounced transformer, because I have 50 ohm coax going into an antenna with an impedance of around 30 ohms. If I didn't have any radials on the antenna, that would hide the impedance mismatch, and I would hook the coax up thinking I had a 1-to-1 SWR, and that was only due to one fact: my ground losses are being hidden, or the impedance mismatch is being hidden by really a lot of ground losses. But because we have around 60 to 70 radials that we share between this and the MA160V vertical antenna on the other corner of the yard, those radials prove that there's an impedance mismatch. And if you don't use the unbounced transformer, that natural impedance mismatch that might be around 3-to-1 SWR, using the unknown goes down to about 1.1, 1.2-to-1 at my lowest resonant point. So this device here is very important. If you're going to put one of these antennas into your backyard, make absolutely sure you have a good matching device with the coax and the antenna. Second thing I want to show you is almost as important, keeping the antenna quiet, is the ground rod. Now, this ground rod here has a copper wire that goes to the common point ground underneath the utility box we just visited, and then I have all my ground radials tied to these little ground buses, and you can only kind of barely see one, but there's several that are buried underneath the ground here. So that's the base of the antenna. The black tape is actually covering the fiberglass insulator. So this is your top of the, or the bottom of the antenna, I should say, right here, with the aluminum piece on the positive side of the feed for the coax. You can't really see it underneath the tape too well, but I've got a lot of RF chokes to keep ambient RFI off the feed line. And of course down here is the base of the antenna. So now that we've taken a look on how we're feeding the antenna, let's go ahead and take a look at how we're hearing on the radio with another antenna called a K9AY loop. Okay, so now we're in the opposite corner of the yard. You can see the MA160 from where I'm standing here. It's about 60 feet away. And right here in front of me is the MA160V vertical. This is fed a little differently. We basically have this choke on here to give me a better resonant point on 80 meters, because I primarily use the antenna for 80. I also have a balun that has a lot of coaxial beads that keep RFI and ambient noise off the feed line, and that's worked out really well for us. And the ground rod's a little more prominent, as are the radials. It kind of gives you a better idea of what we were looking at on the 160 meter antenna that you couldn't see. So the K9AY loop was developed by Gary, K9AY, and we have this in an east-west pattern. I would put it in a northeast-southwest pattern, but we just don't have the room up towards the top of the yard there. Anyway, with the K9AY loop, I can take a stormy night and listen to either the east or west directions, and a lot of times I can pick up stations going one direction that I don't hear going the other direction. And because I'm listening primarily to the magnetic portion of the electromagnetic wave with the K9AY loop, with a preamplifier's assistance, I'm able to pick up the radio signal much better, and while the noise that's usually on the electro side of the antenna, or in our case what would be the vertical side of the antenna on the MA160, is attenuated quite a bit. So we transmit with the MA160, we listen with the K9AY loop, and if you take a look here at the K9AY loop, what you're doing is just kind of looking at the switching relay box here to go from east or west. Here's a case where you can see the RF beads are predominant on the coax. The coax cable is buried deep under the ground, and the ground rod that you see here, the copper runs to the common point ground that we have underneath the utility, and in series we have the MA8040 vertical behind me that goes to the ground rod for that antenna. So all my antennas have a common point ground at the utility ground underneath that box, and that really helps to keep things quiet and to keep things safe electrically for lightning. Okay, so N0 Alpha Hotel back. I'm going to just show you the performance of the MA160V in the backyard, performance-wise as measured by Rig Expert. Antenna analyzer. Let's go ahead and take a look at the SWR first and see where we are, see how we're doing, and see at about 1834, I'm at 1.1 to 1, which is really kind of cool. And if I wanted to do a bell shape curve on it, this analyzer will go ahead and draw it out. And right now I'm about 20 kilohertz wide, which means I'm on 10 kilohertz on each side of that line. And you can see that, just watch how I use the meter here. If I take the frequency and I go down, I'm at about 2.5 to 1 at 1824. And if I go ahead and do the same thing and go up in frequency, notice SWR going down on the line. I'm at about 2.5 to 1, or maybe a little under 3 at 1842. So that's about 18 to 20 kilohertz of usable bandwidth. You throw the antenna tuner in on the TS590S, I could probably get about 40 kilohertz of bandwidth, which is what the manual advertises, but I think they're feeling that most people aren't going to put in the in-depth radial field that we have. And as a result, I think they feel that well, most people are going to get 40 kilohertz of usable bandwidth because of ground losses that they're not capturing with an ideal radial field. Now ours isn't ideal, but it's better than 10 radials. So there's a quick demonstration on the antenna analyzer, just how low I've got the resonant point. And again, remember, if I didn't have that unbounced transformer, my lowest SWR point at resonant is about 3 to 1. And then what, I've got 3-4 kilohertz of bandwidth. So that unbounced transformer, pardon me, is what makes everything work with this antenna. So hey everybody, it's Paul Veal again. Hey, I just wanted to go over the MA160V manual and just tell you a little bit of fact from fiction. First of all, they claim that the impedance of the antenna is 50 ohms. Well, I guess without radials that might be true, but if you add any radials on there, you're going to lower that impedance pretty quickly. So that's one myth. Yes, you can get 1-to-1 typical at resonance as long as you don't hook up any radials. Again, with radials, that's going to be higher. The bandwidth, they're claiming 40 kilohertz. Again, if you don't hook up any radials and you have a huge amount of ground losses, you'll probably get 40 kilohertz out of it. And the height's between 30 to 36 feet. 12 pounds is accurate. You're going to be around 35 to 36 feet if you're in the lower portions of the CW digital portions of 160 meters between, let's say, about 1.820 up to about 1.840 megahertz. And that's one of the reasons I'm glad I'm centered where I am, because as you saw with the antenna analyzer, I can reach kind of the top and bottom of that range, and with my antenna tuner probably get a little more out of it. So there you go. That's what's going on with the manual. It's pretty direct. Drawings are what they are. They don't have anything that shows you what the antenna looks like if it's completely done, and that's the only suggestion I would have on improving that. So let's move on. This is what geriatric dogs do in the morning. They work out. I should work out like Whisper. Be in a lot better shape. Look at that. Working out the nose, working out the forepaws. Way to go, Whisper. Good set. Let's do another one.